Hello. Today we're going to be starting in Module 2, and we're going to be talking about systems of linear equations. And in that, this is something that should be a review for you that you have seen in another math class. But we're going to basically talk about systems of linear equations, how you could solve them graphically, how you could solve them by the substitution method, or how you could solve them by the elimination method. We also want to be able to identify these equations, these systems of equations, in different ways. So as inconsistent or consistent, as dependent or independent. All right, let's get started. So first off, let's look at the three types of systems of linear equations that we might find. So when we have a two variable equations, these are linear equations, and we can see in the first one here, one possibility, if we were to graph these two lines, is that these two lines would meet at exactly one point. So when you're filling in here, the graphs of two equations cross or intersect at exactly one point. Only this solution is true for both equations. All right, moving on to the next one, we could graph them and they would never intersect each other. They would be parallel lines. And so the graphs of two equations that never cross are parallel lines. There are no solutions that are true for either equations. Remember, a solution means, in this context, where those two lines are crossing each other. So if they never cross, there can't be a solution. And the last option here, the third option that we have, is we could have infinite solutions. So if we had coinciding lines, meaning one line on top of another line, that's what this graph is representing, the graphs of the two equations are the same line. Any solution that is true for one equation has to be true for the other equation. So there are infinite solutions on this because every single point that's on this line will be a solution. All right, now let's turn to talk about consistent and inconsistent, dependent and independent. So a system is consistent when it crosses at one point. Right? It's consistent because it has at least one solution. Right? So we've got one solution there, it's consistent. Let's go and look at the other ones. Again, we said these two lines will never cross, so that means the system is going to be inconsistent. There is no solution. And the last one, the system is consistent because, again, it has at least one solution. It has infinite solutions, so it has at least one, so we call it consistent. Now, this first one where these lines are crossing and they cross at one point, right? The system is said to be independent because we can see those two lines are unique, right? They are different lines. They have a different slope on them. Now, on the parallel lines, right, these lines are also unique. And so that means that they would be independent. And this last one, since it's exactly the same line, one line on top of the other line, that means it's going to be a dependent system because those lines are not unique. They're the same exact line.